Good afternoon, everyone. As Neil said, I'm David Nepomuceno. I'm a second-year PhD student at the University of Bristol, and I actually, for my PhD, I actually look at the asset management of bridges, and have also worked on Waterloo Bridge itself on the judicial monitoring side. But today, I'm going to talk to you about damp rather than bridges. Less exciting than satellites, but I'll try to make it interesting. So just an overview of what I'll talk about. I'll just go through the background of why I think residential damp is an important issue to tackle. I'll go through a quick summary of the literature review findings where I try to find certain technologies that show that an urban sensing system for damp is feasible. And then I'll kind of whiz through my case study of where I deploy a single sensor basically in my bedroom and kind of what findings I gleaned from that. And then how I kind of scale it up to a potential university-wide application, and then just end with just a few discussion points. So why is damp important? Or why is damp bad, basically? So these pictures, I'm sure you're all familiar, but hopefully not too familiar. Damp is essentially the excess of moisture, either in air or in a material with no chance of escape. And with that excess moisture, you get a whole host of problems, as you can see. Asthma, mold, and many studies have shown that mental well-being is affected of residents who are exposed to damp on a daily basis. And of course, structural damage when it gets really bad. So basically what interested me at the time of writing this was I came across this paper where a group of researchers in Quebec, essentially they argue that along with the elderly and children, university students could be seen as a vulnerable population, a demographic, which is kind of hard to believe. But with regard to damp, they're also vulnerable, mainly because of two things. Low income status, which essentially means they have less resources to do anything about it, and the frequent tenant turnover of usually, you live in an accommodation for a year or so, you move on, and essentially the household gets, negligence gets involved, so no one takes care of it, neither the landlord nor the tenants. So this kind of just piqued my interest in like, oh, that's an interesting situation. And also looking at having, as you'll see later, I personally experienced damp in my room, sadly. So I kind of looked around in the legislation in the 1985 Landlord and Tenants Act. It does say, for human habitation, a space has to be free from damp. But there's no proper quantification of what damp is, and there's no stipulated definition. So I think that lack of clarity kind of leads to negligence from landlords. And even the World Health Organization says that many regulations and standards don't sufficiently outline this. And just to point out at this stage, you get three, in the damp world, as interesting as it is, you get three main types, and I'll be focusing on condensation today. And with condensation, you can effectively measure it with relative humidity, the indoor temperature of a room, and from those two, you can infer a dew point, which is essentially the temperature at which a body of air starts to condense. So essentially, for those not familiar, the closer the temperature is to the dew point, the higher the relative humidity is in the room. So moving on to a literature review quickly, I essentially just went out to find any potential solutions to this problem, either like technologies that can enable a system or systems that are out there that are tackling this problem or could be used. And essentially I found three existing initiatives that are kind of like commercially available or available to use, and 6 emerging solutions. So just to whiz through them quickly, I found 3 initiatives. So starting with the first 2, you have Air Quality Egg and Smart Citizen. And these are commercially available sensors, which some of you may have come across, that can measure a whole host of air quality factors, but most importantly in this study, temperature and humidity. And as well as that, you can connect these nodes to a web-based platform where you can see your own, this is pretty ubiquitous now. You can see your own node and other people's nodes. You can click wherever you are in the world, you can find what someone's humidity is like if you really cared about it. But so these don't, in their descriptions, they're not like we can tackle damp, but these could effectively be used for that issue. But moving on to what I focused on in this study is this Damp Busters initiative, which is essentially a low-income community in Bristol came together, and the Knoll West Media Centre kind of got them together and got them to brainstorm problems they have in the community that technology could potentially solve. And one of them was residential damp. So long story short, they made this nice-looking frog, and they made 9 of these sensors and deployed them in different households. And long story short, they were able to quantify, just to track back, these sensors could measure temperature and relative humidity every 5 minutes. And essentially, over the period of deployment, they were able to quantify the level of relative humidity in their household. And a few of them actually took it up to their landlord and took it up to the council when when the landlord wasn't doing anything about it, and thus action was at least taken. So it was a good step. And as you can probably tell, it's quite at a basic stage at the moment, and work is still ongoing with it. And moving on from that, just to some of the emerging solutions, which are all kind of obvious, to be honest. There are online platforms out there in the academic sphere. You have sensor nodes. Plenty of examples of these that can measure temperature and humidity. You have many of these systems which already essentially have this system where you can take the relative measurements and share them around. Even more examples, and here you can see the network infrastructure is available for these kind of things. And it all just goes to show that an urban sensing system for damp is feasible. Nothing world-breaking or groundbreaking, but no one had. I didn't see anyone who had done this before, especially in this context. So it's good to know. So moving on to the case study, just to provide some context, the Bristol Student Union in the academic year of 2014 published a student housing survey, and which focused on people living in privately rented accommodation. And they had 856 respondents, and 75% of them said mold and damp was present in their household, which is quite a daunting number. Kind of even worse, 20% of them said they had inactive landlords, which are unresponsive to any of their requests. And another daunting figure is that 30% said they wouldn't recommend the university based on this, which is kind of bad publicity for Bristol, so maybe they shouldn't record this. And it all came to a head. There was this point when I was in like 3rd or 4th year or something where protests were going out to landlord agencies to essentially just, hopefully have some sort of change in this. So moving on to the case study, this is the case study building, which is essentially my flat. And you can see there are damp patches present all over the house. And more specifically, so the building was a 5-story home with 4 stories above ground and 1 story in the basement. And lucky me, drawing out of hat when we were choosing rooms, I got the basement room. So this is my room, and hopefully you can see from the photos some damp patches on the ceiling coming through. And I just definitely felt like there was damp in my room and it was all moist, and I'm usually like sensitive to allergies, so I was like, there's got to be a way to quantify all this. So I essentially used a tracking back, to combat this. I had a little dehumidifier and an electric heater in the room and a vent which was behind a table, but which kind of helped alleviate the damper moments. And I used the damp sensor from Damp Busters, which essentially is just a Raspberry Pi 3 with a DHT22 sensor. And this, took temperature and humidity readings every 5 minutes. And I did this over 2 weeks, from the 28th of Feb to 12th of March back in 2017. And I was able to gather indoor temperature and humidity, and I was able to get outdoor temperature and humidity from a local weather station. And from that, I could infer the dew point as well. So just as a quick overview of the data over the 2 weeks, the solid line at the top. So essentially, that's the indoor temperature there. Is this no? The solid line at the top. the light gray areas is when I logged when the heater was on in my room, and then the darker areas was when the dehumidifier was on. So I thought it would be a good way to track if this was actually doing anything and helping combat anything. So just some overall statistics. I guess the important one here is that the mean humidity in my room is 56.5, and the general recommendation for safe levels is 55%. So that way I was able to at least quantify that this isn't good. It even reached nearly 70% at one point. And just some interesting observations, I guess. You can see the indoor heater worked to some extent. You can see that it kind of stabilizes when the heater was on in these patches here, and then when turned off, it kind of slowly goes back down. However, it was kind of inconclusive as to whether it was actually doing anything with the relative humidity, because some days it would go up and some days it would go down. And yeah, further evidence here of just what was going on in the room. I'll move on from this because we're kind of running out of time. And essentially, I just took simple correlations to see when the heater was in operation, did the indoor temperature have any effect? And essentially, it had an effect on the dew point, as we can see, but it's kind of the temperature difference, which is what we kind of want to look out for, as the higher the temperature difference, then the lower the relative humidity. And you can see there isn't really much of a correlation there, though you could say that there is. And I did the same for when the dehumidifier was in operation. As you can see, as the temperature went up when the dehumidifier was on, some evidence to suggest that the temperature difference between the dew point and the indoor temperature would increase, lowering the humidity. So in terms of value, I was just able to gain an awareness of the damp dynamics in my room. However, there was lots of room for improvement, where real-time visualization would help, because I'd had to get the data over the 2 weeks, and then I could kind of see what was going on. And it would have been a nice idea to pair this with automatic actuations as well. So in the paper, I kind of present a conceptual feature system architecture for this. So if you imagine a household environment where you have a student and the damp sensor and their phone, you could connect this to a backend which could process all the data for the dew point, bring up a map-based visualization there, which could either be fed back to the sensor or back to a smartphone. And moving on, looking at the more social aspect, this data could be sent to relevant stakeholders, so either city councils, to landlords, or to universities. And even to keep it relevant, you could even post it to social media. So just an overall statement of value is that this system would enable the quantification of damp, and I think the important thing is that it would encourage community engagement and enhance the digital infrastructure in such an area. And just to end with some discussion points as to whether this is actually a feasible thing that could be rolled out. One important thing I kind of realized is, do students care enough about this? You're only living in a room, you're living in a house for like a year, so do you really care? I mean, asking my friends this question, they were like, no, for this to be rolled out. So that you could argue that it would lead to low adoption. And obviously there will be many different stakeholders, so it may be good for tenants, but will landlords want this data to be public? Because then all the houses with high levels of damp could essentially be exposed and lower their reputation. And obviously, who owns it? Because it's the tenant that's using it, but then the landlords could also have a stake of who actually owns it. And obviously, who can access the data, which is very relevant at the moment. So that ends my talk, and hopefully I made it relevant, relatively interesting. But any questions, please?